I'd like to look at some polar graphs called rose curves. And before we graph them on paper, I'd like you just to see their beauty on the computer. I'm going to use Desmos for this. And I have graphed r equals 5 sine 2 theta. That's a rose curve. Notice that there are 4 petals for that equation of r equals 5 sine 2 theta. I also want to point out to you that the radius is equal to 5, or excuse me, that the petals are of length 5. I'm going to graph an equation that represents the circle with radius 5 so that you can see that the petals all just are tangent to that circle that has radius 5. So the petal length is 5 units. So let me make that circle go away so you can just see the rose curve. Let's look at another one. The form of the equation is similar. It's r equals 5 sine 3 theta. Notice it's still a rose curve, this time with 3 petals. And here's r equals 5 sine 4 theta. Notice it has 8 petals. But again, each petal length is 5 units. This one, r equals 5 sine 5 theta, is a rose curve with 5 petals. R equals 5 sine 6 theta is a rose curve with 12 petals. So let me point out that what seems to be the pattern, that if our value here, the coefficient of theta, is even, we have double that number of petals. Here was a 6 theta and we had 12 petals. Here was a 4 theta and we had 8 petals. Here was a 2 theta and we had 4 petals. However, when the coefficient of theta is odd, we had just that number of petals. This was r equals 5 sine 3 theta. Here's r equals 5 sine 5 theta. And I didn't put it in, but let's even pop in right here. We'll make this be a 7 theta. Notice we have 7 petals. And we'll see that that will hold true regardless of the coefficient of theta if we put in an integer here. So I could even make it a 17, and we would have 17 petals there. I want to just mention this before we actually graph some by hand. Right here, this is r equals 5 sine theta. The coefficient of theta is 1. It looks like a circle, and in fact it is, but I often think of it as just a one-petaled rose curve when I'm graphing with polar coordinates. So now let's see how we'll come up with these by hand, keeping in mind that we're looking at these rose curves. So let's move away from the computer, and we're going to do this by hand. Let me move the computer out of the way here. And let's start with r equals, let me make it so that you can see it. We'll be over here. R equals 8 sine 2 theta. Now we want to come up with the graph for this. Hopefully after you've done a few graphs, you'll look at that and recognize that it's a rose curve. But when I'm coming up with them, I often look at the graph with rectangular coordinates and translate to polar coordinates, because hopefully y equals 8 sine 2x is something that you're familiar with. In fact, let's graph it. We know that the amplitude will be 8. The period for this one will be 2 pi divided by 2, so pi units. So the period is pi. And I'm going to cut that into quarters, so I have pi over 2, and I have pi over 4, and I have 3 pi over 4. And we know we're talking about the sine curve, so we'll go through 0, 0. It goes up and back down to 0, and then it will come down here. So if I graph one cycle, it looks like this. But let's continue. Let's graph one more cycle. Let's finish out here at 2 pi. So we'll go up and back down. And so we have a picture of the graph of y equals 8 sine 2x from 0 to 2 pi. We know the amplitude is 8. And we know this is x and this is y, but we're going to translate it. So we're going to think of this as theta, because we're trying to get this equation graphed with respect to polar coordinates. And we're going to think of this as r. Now we have the benefit of having explored our rose curves on the computer a little bit ago, so that will help us figure out what the graph is going to look like. So let me move up a little bit so we can see it. So here's my theta, and here's my r. So let's look at what this tells us. It tells us that between 0 and pi over 4, the r value is getting bigger and bigger and bigger until at pi over 4, we're at 8. So the graph will start here, and at pi over 4, we'll be out at 8. So pi over 4 is here, 2, 4, 6, 8. And the r values will get bigger and bigger in between there. It's worth noting that the graph is actually going to be tangent to the lines at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Any place where the graph goes through the pole, the graph will be tangent to it. And the graph is going to go through the pole every place where the rectangular graph goes through the x-axis. So I know my graph is going to go through the pole at pi over 2, and I'm just going to put a dotted line right here at pi over 2. It'll make my graph be a little bit nicer. And at pi, and notice I'm extending it all the way across, and at pi. And at 3 pi over 2, but I already have that one in, and at 2 pi, and I already have that in as well. So the graph will be tangent to those lines that I have in. So let's draw our curve. From 0 to pi over 4, the r value gets bigger and bigger. It's tangent to this. That means it's kind of running along this, but it's going to curve in this direction. From pi over 4 to pi over 2, the r values get smaller and come back to the origin or to the pole where r is equal to 0. So my r values get smaller and smaller. So let's do that. Smaller and smaller, and then it will be tangent to this line. And I have one petal of my curve. Now it continues and it's tangent. Let's see what happens. From pi over 2, you can't really read that very well. That's a 3 pi over 4. So from pi over 2 to 3 pi over 4, the r values go negative. So from here to here, from here to here will go across the pole. In fact, from pi over 2 to pi, the points will be over here because the r values are negative. So we'll go out to 8 and come back into the pole. So at 3 pi over 4, my value will be negative 8. So I'm going back this way. Negative 8 is right here. My petal will, the graph will continue to be tangent there. And come back in and be tangent again. And tangent means just touch along that line. So here was the first petal. Let me represent it this way. The first petal we got from this piece of the graph. The second petal we got from this piece of the graph. Let's move on. Between pi and 3 pi over 2, our R values are positive. So from pi to 3 pi over 2. So from here to here, our R values are positive. Notice that this is 3 pi over 2 here. So this must be 5 pi over 4. So at 5 pi over 4, I will be out at 8. So let's go out to 8. So my graph will go out to 8 and back down to 0. So again, it's tangent to these lines. So out to 8 and come back to 0. So this piece of the rectangular graph translated to this petal right here. And finally, from 3 pi over 2 to 2 pi, notice our R values are negative. So from 3 pi over to 2 pi, R values are negative. It'll throw us over to here. We will again go out to 8. And our graph will look something like this. And we have our rose curve drawn. This piece represented our fourth petal right here. Let's draw another one. So let's graph this time. We'll graph R equals, we'll make it 6 sine 3 theta. So there will be the graph. Oop, you can't see that? There, now you can. R equals 6 sine 3 theta. So I'm going to translate the graph in rectangular form into my polar graph. So I'm going to graph y equals 6 sine 3x. This time, remember, our period will be 2 pi divided by 3. So every 2 pi over 3 units, I will have one cycle. So here's 2 pi over 3. Then I'll have another cycle getting to 4 pi over 3. And then a third cycle will get me to 2 pi. So let's graph. Notice our amplitude is 6, up to 6, down to negative 6. So let's graph. We'll go up and back down. Here's one cycle. And let's see, we'll cut this in quarters. Here's our next cycle. Oop, didn't look very good. Let's do another one. We'll go up to 6 and down to negative 6. So here's our grid in rectangular coordinates, but remember we're translating to polar. So this will be our theta. These are our theta values, and these are our R values when we make that translation. Remember on the previous problem, each of these represented, each hill and valley represented a petal. So initially it looks like if we compared it to the previous one where we had 4 petals, it would look like we'd have 6 petals because remember it was petal, 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 petal. Let's see what happens when we translate that to this grid. Now, remember we drew in those tangent lines and they came from our x-intercepts. So let's draw those in. Let's see, here we have 0, pi over 3, 2 pi over 3, and pi. Let's put all those in. So I have 0 pi over 3 and 2 pi over 3. And we also have 4 pi over 3, 5 pi over 3, and 2 pi, but notice they're already drawn because I extended the line all the way across. 4 pi over 3, 5 pi over 3, and 2 pi. So those tangent lines are already drawn. So let's translate from rectangular to polar. So here we go. From 0 to pi over 3, we go out to 6 and back to the pole. So from 0 to pi over 3, I'm starting at the pole. I'm going to go out to 6. So let's see, 2, 4, 6 right here. And I'm going to be tangent to these lines. So I'm going to go out to this point and come back in. And here we go. So this petal came from this part of the graph. So there's petal 1. Let's continue. From pi over 3 to 2 pi over 3, we go across the pole because our R values are negative. So from pi over 3 to 2 pi over 3, our graph is actually down here. Notice we'll get 6 units away from the pole. So here's my 6. I'm going to be tangent to this line though, so I'm going to use that as my graphing guide. So tangent to that line, come out, and then come back. So here's petal 2. Right here. Now let's move on between 2 pi and pi. So, 2 pi over 3 to pi. 2 pi over 3 to pi. I go away from the pole out to 6 and come back down. So from 2 pi over 3 to pi, I'm going to go out to 6 and come back to the pole. So here we go. And again, we're going to use those lines as our tangent lines. And it looks like this. So here is petal 3. Right here, came from this part. Now let's move on from pi to 4 pi over 3. So now we're talking about from pi to 4 pi over 3. The R values go negative. So from pi to 4 pi over 3, pi to 4 pi over 3, the R values go negative. That means it comes across the pole and we're over here. And you'll notice we get this petal again. So this piece of the graph gives us a duplicate of a previous petal. Similarly, from 4 pi over 3 to 5 pi over 3, 4 pi over 3 to 5 pi over 3, our R value is positive, we would get this petal again. And from 5 pi over 3 to 2 pi over to 2 pi right here, I go across the pole because my R values are negative, and I get a duplicate. And this is why when our value here is odd, we end up with just that number of petals because all of these are duplicates. So if you have R equals A sine n theta, if n is odd, you have n petals. If n is even, you have 2n petals. And that's we could see it on both the previous example and this one. Let's graph what a function like this, no, excuse me, not a function. This is definitely not a function. A polar graph like this with cosine. We've only looked at sine. Let's look at what happens when we put a cosine in instead. So let's make it be this. We'll have R equals 5 cosine 2 theta. So very similar to the first graph that we did, but now we have a cosine instead of a sine. But again, I'm going to go back to my graph, my rectangular graph, as a reference. So I'm looking at y equals 5 cosine 2x. As you know, the period will be pi. So from 0 to pi, I'll have one cycle, and from pi to 2 pi, I'll have another cycle. So let's cut that up in quarters again. We know our cosine graph looks like this, though. So one cycle of our cosine graph would look like this. Notice our amplitude is 5, means our petal length will be 5. Assuming that it is in fact a rose curve, but it's not going to be a surprise to you, I don't think at all, because our sine and cosine are so closely related. So here is our graph from 0 to 2 pi. Again, this is x and this is y, which we're going to translate into theta and r. So our theta values will go from 0 to 2 pi. Our r values from -5 to 5. And again, I want to put in the lines that will be our graphing guides for this particular grid, for this particular graph. And remember, they are any points where the graph crosses the x-axis, means it will be crossing the pole, moving through the pole. So let's see, this was pi, this is pi over 2, this is pi over 4. This is 3 pi over 4. This one right here is 5 pi over 4. And no surprise, that is 7 pi over 4. So we can draw in those lines at pi over 4. Let me extend it. And 3 pi over 4. Let me extend that as well. And 5 pi over 4 is already there, and 7 pi over 4 is already there. So when we draw this particular graph, we'll use those as our graphing guides, and here we go. From 0 to pi over 4, notice it's 0, we're out at 5. So when theta is 0, we are at 5 units out. So 1, 2, 3, 4, 5. Here's 5 right here. And the r value gets smaller and smaller and smaller until we get to pi over 4. So it comes in and it's just tangent right here to that. That's our little graphing guide. We get to here. And we have half of a petal. Now let's continue from pi over 4 to 3 pi over 4. So on our graph, let's see where that is. Pi over 4 to 3 pi over 4 is right here. But this is showing us that our values are negative, so we go across the pole. So now we're down here, and we're going to move out 5 units from the pole. So we're at 1, 2, 3, 4, 5 right here. And you could confirm that at pi over 2, you're at negative, you have the point -5 pi over 2. So we're looking at pi over 2, we go backwards 5 units, we're right here. So this represents, right here, this petal down here. From pi over 4 to 3 pi over 4, again, we're talking about this. We go across the pole because of the negative values. We end up with this. Again, make sure I use those little tangent lines. There we go. And I'll call that petal 1. We only had half a petal, so I'll just call this petal 1. And now we move on from 3 pi over 2 to 3 pi over 4 to 5 pi over 4. Where are we? 3 pi over 4 to 5 pi over 4. We're talking about this. Our r values are positive. We're going to go out to 5 and come back. So from here, we're going to go out to 5 and come back in. and we have another petal. So this represented petal 2. Now from 5 pi over 4 to 7 pi over 4, where is that? 5 pi over 4 to 7 pi over 4. Our R values are negative. We go across the pole and we have another petal. Using those dashed lines as my graphing guide, I know it comes out, comes back in. So this represented petal 3. And very last, from 7 pi over 4 to 2 pi, our R value is positive. So from 7 pi over 4, which is right here, to 2 pi, R value is positive, and it finishes off the petal that we started at the very beginning. So here was, this was petal 3 up here. And here is petal 4, and petal 4 was actually in 2 parts, right here and right here. Those together gave us petal 4. But again, notice we have a rose curve. So R equals A cosine n theta is also a rose curve. And if n is odd, you will still have n petals. I didn't do one of those. We just did one where n is even. You have 2 n petals. So hopefully you will be able to graph any rose curve. Before we finish, I want to do one more graph with you. And we're going to do a problem that looks like this. R equals 6 sine theta. Now you could think of that as a rose curve with one petal. I can even draw my rectangular coordinate system, my rectangular graph, I mean. Y equals 6 sine x. You know that is a graph with a period of 2 pi. Oop. Here. I don't know what that point's doing up there. We want the point here and here. So it goes up and back down. And if we get our polar grid here, and let's think of it the same way. Our tangent line at 0 pi and 2 pi, there's 0. And 2 pi and 2 pi, they're all that line. So between 0 and pi, from 0 to pi, the graph will go out to 6 and come back in. So out to 6, that's 2, 4, 6. It will go out to 6 and come back. And it's tangent down there. And we have it drawn. Remember that this will be a duplicate right here. This is our circle. This generates the circle. If you looked at from pi to 2 pi, our values are negative, you would generate the circle again. This part duplicates that circle. But we can figure out the orientation by just looking at our rectangular grid and translating it into a polar graph. So let me be clear. If you have R equals a sine theta or R equals a cosine theta, you will have circles. Now, I haven't confirmed that that's a circle. I mean, I could have made it skinnier. How do I know it's a circle? And let's finish with this. Let's confirm that this is, in fact, the equation of a circle. And we're going to do that by converting from polar form to rectangular form. So I have R equals 6 sine theta. Remember, when we're converting from polar to rectangular, we want an R right here because we know R equals, or X equals R cosine theta. and y equals r sine theta, and x squared plus y squared equals r squared are our relationships that we use when we're talking about polar and rectangular equations and points. So let's multiply both sides of this equation by r, and we'll have r squared equals 6r sine theta. We know r squared is x squared plus y squared. We know r sine theta is y. So if we set that equal to 0, we would have x squared plus y squared minus 6y equals 0. I hope you can recognize this as the equation of a circle. Let's just do a tad bit more. Let's complete the square by adding 9 to both sides. So we'd have x squared plus y minus 3 squared equals 9. And now I hope you recognize from your work with rectangular graphs that this is a circle with center at 0, 3, and the radius equals 3. And if you look back at our graph, it wasn't a beautiful circle, but notice here it was. Center in our rectangular coordinates right here at 0, 3, and notice the radius is 3. Alrighty. Now I hope you can go graph some rose curves and some circles.